Okay, for those curious, I've now switched this Mendel over to a computer power supply. There's the board back there. Up until recently I was using a regular industrial power supply. Now I'm using a 3.5 amp power supply. I get them cheap. I get them about 10 or 12 bucks, so that's fine. It's powering a logic board. I'm still going to use that logic board. I'm getting ready to interface it with this so it doesn't need this computer. This computer is running Mach 3 and it's been doing my work for simulation, for testing. So anyway, what I wanted to show you here is without the extruder on it. This is a prototype. I'm going to add another motor here, and I'm going to add another motor here because I want it to stably run at 240 inches per minute, which is, I can do it with one motor on each end, but the force involved is enough to vibrate the screws loose. So I'm going to see if having two motors makes it work. So here is there's prototype X. There's Y. Y I slowed down a little bit. I'll speed it up later. And then Z. So let me excuse my workbench, but there's Z. And there's I changed the Y bed so that the back has a circular arch to it, so it goes farther, because you have the flywheel back there that helps things spin faster, that can help the motor run faster. Let me go ahead and see if I can configure Y. I don't think I can get the high speed anymore on Y with my new design without it skipping. So I'm going to have two motors there. Let's see, I'm just configuring Y, so see how it does. There we go. So I tried several different designs. I wasn't going to originally have bearings on the Z-axis, but this is how my Z-axis is. These bearings go in and wedge. They don't go diagonal because that's pretty expensive to design for. I could design for it, but why? It takes up a lot of space this way, and this works pretty good. This doesn't move. Here, I'll show you how stable it is. See, you don't see it moving. So this doesn't allow as much degrees of freedom as the regular Mendel axis, but and it uses I think 2 more bearings, but it's a lot easier to design for. And what you would do is you just tighten up here, and that will make these straighter and make them push in a little bit. So there's no play. You see the other one over here is like that too. There's no play in it, and it works great. I have a design where the motor, this part clips in, holds the motor in, and then the back of the motor, along with the plastic, holds the nut in place. So that's how the nut's held in place. You might be able to see the nut in there. There you go. You can see the nut. So I'm working on a little bit more work on my Z-axis. But you can see with the 2 motors thing, it works pretty good. And then I got my Z stops and my stops to put in. And yeah, I still got a little play. I got to put something in bracket to hold this in, because with the motor pushed back here, this should actually have no play. And I also need to tighten the washer up here so that this doesn't have any play at all. Right now this has a little bit of play, but I'm getting rid of this. I got rid of all the play in the stage, so with a threaded rod, there is now virtually no play in the bottom axis. Alright, anyway, that's my Mendel. Tomorrow's video, I'll probably have the extruder on here and have this actually printing out parts. This is my redesign. I'm also probably going to have another motor on here and another motor down here. And my goal kind of is to have this run and process so fast that you can't even see it move. So it's one to move blurry. Well, anyway, that might be hard to reach, but this printer is going to kick some ass.